Okay, this is the first video that I'm going to record on logarithms. Logarithms are our next unit. This is going to be a longer video. You guys are going to have to take notes because it's the very beginning of the unit. So I'm on page 2 of your new logarithms functions packet. Now, we're going to go over two methods for solving exponential equations. I need you guys to write these two methods down. So if you want, you can pause the video now and write these two down. The first method, when the bases are the same, we set the exponents equal to each other. We went over this in the last unit. So if we can get our bases the same, set our exponents equal to each other, then we just focus on the exponents. Now, there are examples where we can't get the bases the same. So we need to use logarithms. Now, to kind of explain why logarithms are needed, I want to talk about inverse operations. So, different inverse operations we've used. Let's talk about addition. The inverse operation to addition is subtraction. Another one, let's talk about multiplication. The inverse operation of multiplication is division. These are ones that you guys know. Now you're going to learn that for exponentials, the inverse operation is logarithms. So, the reason why inverse operations are important, what do inverse operations do? They allow you to solve for variables. Let's do a quick example. For example, 3x is equal to 9. 3 times x, I'm multiplying, so we do the inverse operation, which is division, to solve for the x. So I'm going to divide by 3, and x is equal to 3. That's an example when we use inverse operation. So now when we have exponents as our variables, we're going to have to use the inverse operation of logarithms to solve for what x is. All right, so let's look at these examples here. And I made this little graph here. When solving for an exponent, can I get the bases the same? Yes. Then I want to set my bases the same and set the exponents equal to each other. If I can't get the bases the same, I take the log of both sides. So, looking at this first example, can I get the bases the same? I know that I can get my base to be 2. 4 is the same thing as saying 2 squared. So this can become 2 squared times 2x. And 8 is just 2 times 2 times 2, which is 2 to the third power. And I have this x plus 1 here. So now that my bases are the same, I can just focus on my exponents. So 2 times 2x is equal to 3 times x plus 1. This is going to be 4x. This is going to be 3x plus 3 after I distribute. And now I want all the x's to one side. Minus 3x, minus 3x. So I get x is equal to 3. You guys can try this one on your own. This one, you can get the bases the same. Start this one. 27 is 3 to the third power. And this 3, if I want to get it on top, I can make this 2x, which is on the denominator, a negative 2x if I want to flip it to the top. Now my bases are the same. Set your exponents equal to each other. Finish that one for homework. This one, I can get my bases the same. My bases are going to be 5, because 125 is 5 to the third power. 25 is 5 to the second power. Now my bases are the same. Set my exponents equal to each other. Do this one. Finish this one for homework. Now let's look at this example. I'm on page 3 now. 2 and 7. I can't get those bases the same. There's nothing that I can do to get those bases the same. So now what I have to do is I have to take the log of both sides. Whenever you have x in your exponent and you want to solve for it, the inverse operation of exponentials is logarithms. So I can take the log of both sides. Log is short for logarithm, so we can just take the log of both sides. Now, taking the log of both sides is going to look something like this. Log of 2 to the x is equal to log of 7. So, the power rule in logarithms is, as long as you take the log of both sides, you can bring down whatever your exponent is. So this becomes x times log power of 2 is equal to log of 7. Now if I want my x alone, now that it's dropped down, I can divide by log of 2, divide by log of 2, and x is equal to log 7 over log 2, and this is what my answer can stay for now. All right, I want you guys to copy down these 3 definitions of logarithms. So, logarithms, numbers written in the form of log with base b to the x, where x is greater than 0, b is greater than 0, and b is not equal to 1. Common logarithm is a logarithm that uses base 10. So, whenever we have a base, this little number here is 10, it's always invisible. So, log of base 10 becomes invisible. Notice I don't have the 10 anymore. So that's invisible. Natural logarithm is whenever you have base e. So log with a base e here, log of base e automatically turns into, this is ln, called the natural log. We're gonna go over that tomorrow in class, but I want you to have all of these definitions down in your notes so we can go straight into learning about common logarithms and natural logarithms.